Moving on, let's have a look at a few examples of questions that you could potentially be asked to do. Now in example 1 it says, draw the network as described in the connectivity matrix below. So what we have is a connectivity matrix C defined as seen over here. What we're going to do is we're going to generate the graph of this particular connectivity matrix, or the illustration of this connectivity matrix, that will help us be able to see visually what's going on. Now looking at this, first thing I'm going to do to approach this sort of question is I'm going to label the rows and the columns. So the columns are going to be A, B, C, D, E. Again, they don't have to be E, but so long as they're in alphabetical order, it makes sense. Like so. Then the next step is we need to count our rows and columns, and that will be how many nodes we're going to have. So in this case, we're going to have 2, 4, 5 different unique nodes. So what I'll do is I'll draw in my nodes here. Nice, neat node. Okay, now we're going to have 5 of these guys. Done. Now the next thing is we need to decide which node are we going to start from. Now the way in which I like to do this is I look in the table and I look for the node that has the most amount of edges coming off it. Now the candidates for this could be either B, because there are 3 edges coming off B, or it could be, say, for example, D. So D here and here. So D has 3 edges as well. In this instance, because B and D are connected, I'm going to line them up together with one another. Now in terms of laying this out in your books, what it might be a good idea is just have a few light sketches, so rough sketches to estimate on how you might lay it out. Chances are you won't be asked to do something overly complicated, but we could ask you to do something that is a little bit mean, a little bit does require a little bit of forward thinking. Now, B and D, they're going to be here and they're going to be here, and there's a single edge. Now, next one is we're going to have a look at A, because it's connected to B in quite a simple way. So A is only connected to B, as seen by this part here, so A and B. So as a result, I'll just hook them together as like seen. And then the final outstanding nodes we have to hook into this are C and E. So C is connected to B as well as connected to D. So what I'll do is I'll put a node that looks something like this, and we'll say this is node C. And then the outstanding node is E. So we've got E and it's connected to D. Its only connection is with D. This is what our network or our graph would look like going from our connectivity matrix here. Remember, it's important to be able to think ahead of what the graph might look like, so that way you don't start drawing really neatly and then find, oh no, I've got to change it because it's not going to work out. Alright, question B. Compute the second and the third order connectivity matrices. Now looking at this, we know that our first order connectivity matrix is of order 5, so therefore our second order connectivity matrix is also going to be of order 5, as well as our second order is going to be of order 5, as well as our third order 5 as well. So pre-planning these, this will be my second order, and this will be my third order. Now to be able to calculate these, you've got the option, you could painstakingly trace the second order matrix from the network graph as seen over here, or you could take the more sensible option and you can just use your calculator to do it. Now I've already gone ahead of time and input the matrix into my calculator as matrix B here. So all I need to do from this next step is I simply calculate it in my calculator. So going from option F2 for matvect, mat, in my case it's in memory slot B, I'm going to go matrix B squared. This is going to yield me the result of the second order matrix. Of important note is the fact that this entire matrix is able to fit on a single screen as seen over here, as opposed to what we saw in the example up here. What I recommend is make sure you're practicing. So when you're doing some practice, make sure you do it with some matrices that fit off the screen. Reason being is that if you get asked to do a particular question like that in a timed assessment, you're less likely to make an error if you practice your algorithms of transferring the information shown here over to here. It might sound simple, but you'd be amazed at how easy it is to make a mistake, as you saw me do when I was transferring the information over here. Anyone can make a mistake. Alright, doing the second order matrix, I can just go up and I can change this 2 to a 3. And here is our third order. Then going back and putting in my 1s, what you may have also noticed is that I'm writing all of my 0s in red. The only reason I'm doing this is for a stylistic option. Makes it easier to see where the 0s are. Nothing more. There's no mathematical idea behind it, except for the fact I want to show that these are 0. And thus, we conclude our example of how we can go about transferring network matrices into our diagrams and how we can calculate second and third order connectivity matrices from a first order connectivity matrix using our technology.